So on page 28, if we picture this function, and look what it says. This is the function sine of x to the 1/2 between 0 and pi. And you guys, it is rotated about the x-axis. I'm going to rotate it about this x-axis, right? And when I do, how I would draw it if I were you is I first like to reflect what they gave me. This is like this function that I reflected. And then if I rotate that about the x-axis, do you agree it looks something like this? This is when we got to try to be artists. And my question is, what kind of candy might I have been able to buy to signify this solid shape that'd be formed when I revolve that? Someone else said a baguette. I hear you. I didn't buy everyone a baguette. A jelly bean, that could be a solid. I didn't buy a jelly bean. Would you say that looks pretty accurate, guys? When we revolve every single time, what's that shape going to be of that cross section? It's going to be a circle. You guys, in order to find the volume of this thing yesterday, we found the area of the cross sections and added them up. Guys, we're going to do the exact same thing. The cross sections now happen to be what shape? A circle. How do I find the area of a circle? Pi r squared. People, here's what we got. We got to add up pi r squared. Could your pi go in front of my or behind my integral? For sure. Yeah. Don't care. Because it's just a constant. Here's my question. Of this cute little Hershey's egg, what's the radius? What's the radius? The radius depends on the height, which is denoted by the function, the f of x. Exactly. So isn't this going to be sine of x to the 1/2? And this is as well wherever x is. So you guys, we got pi, my radius, squared. From what bound to what bound? No calculators yet. 0 to pi. Oh, yeah. So you could have written f of x if we weren't doing this by hand. Good call. And actually, bud, we would have to put y instead of f of x because of how they labeled it. Okay? So I'm going to have us do this by hand. Before we do this by hand, I have to get rid of those exponents, meaning 1/2 times 2 is going to cancel out. And I know the volume. We're simplifying this. Would just be the sine of x. Daria, that's great. We need to do that. So before we have vom of the mouth, whose derivative is sine? Negative cosine. Instead of me saying antiderivative of sine is, then I feel like we all blurt out cosine because that's the derivative of sine. We got to think whose derivative is sine? Negative cosine. We're going to then evaluate that from my bounds 0 to pi. Without a calci, we're doing this upper minus lower. So pi times negative cosine of pi, that's plugging in my upper, minus pi times negative cosine of 0. You could have kept the pi factored out with parentheses, but I just kept it with both. Doesn't matter. We got to think about the cosine at pi is -1, right? But then you're saying a negative times negative is a positive. So we'd have a pi minus a pi times, what's the cosine at 0? 1. Make it a -1. Negative pi times a -1. Final answer, 2 pi.
What?
So it says rotate the region enclosed by, do you agree, x squared? This is x squared. I just cut it off for you. There's x squared. Y equals 0 is green. X is 2 is blue. Rotate that about the x-axis. I've got a picture of this. So you guys, if we're rotating this about the x-axis, here's my best help on how to do that. First, I would reflect my function. Then I just give myself a chance to draw these cross sections. And maybe you only need one, or maybe you want to try a couple of them. But does it look like a Hershey kiss? Maybe a little bit. And that's the kind of positivity I like. I appreciate it. Okay, You guys agree this looks like a Hershey Kiss? To find the volume of this Hershey Kiss on its side, to your point, we got to take all those circles and add them up. How are we going to do that? Nelson, do it.
Pi integral 0 to 2
Ooh.
x squared dx.
Wow. Did he say, oh, well, my cross sections are circles. The area of a circle is pi r squared. How'd you know r was x squared, bud?
Because that's the function.
It's just the function. It's the function. It's always going to be the function. No, so what if it was upper minus lower? What was my lower here? Exactly. We didn't have to worry about it. Guys, we are smart people. Let's simplify this before we integrate it. X to the second squared. X to the fourth. Now we're ready to integrate it. Antiderivative x to the fourth. X to the fifth over 5 from 0 to 2.
Well, it's going to be 0 on the other side.
What's 2 to the fifth? And Colin, if we think that, don't even worry about it. Let's just leave it as 2 to the fifth. So we'd have pi times 2 to the fifth over 2 minus
0.
Agreed. We could throw a 0 in there. We don't even need it. What is 2 to the fifth if this was multiple choice?
16.
Like 2
No.
32.
Oh, over 5. Thank you, Chloe. 2 times 2 is?
4
Times 2.
8.
Times 2?
16.
Times 2.
32.
32. So we'd have 32 pi over 5. Ooh, what do we have here?
revolve around the y-axis.
Oh my god, no way.
What'd you say, Healed? It's a what?
A dot.
It's a dot.
Take another Hershey's egg.
Here we go. Consider the region. Shh. First quadrant. They're talking about this region, and it's enclosed by, do you agree that this red graph looks like a negative x squared shifted up 4? Find the volume of the solid formed by revolving this around the y-axis. So now we're going around the y-axis, you guys. So I would go ahead and reflect that over the y. And then we have these cross sections. Ooh, that was a good one if you ask me.
I'm an artist.
Yours are looking good.
As good as it's ever looked.
From
0 to 4.
Healed said this looks like a dot. I agree. We're going to go find the volume of that dot. Okay, peeps, with respect to the y-axis, as soon as I see that, I better be doing dy.
Oh. You don't have to.
Now, what would those bounds be of this graph?
0 to 4.
0 to 4 on the y-axis, agreed? You guys, what are these cross-section shapes? Anytime I revolve? Circles. What's the area of a circle? Always. If I'm revolving anything, there's no way to have anything but a circle. Good call. Yes. She says, are we going to have to switch it around? Since I got a dy here, yes, ma'am. We got to put this in terms of y.
Square root of 4 minus.
So I'm going to say positive x squared equals 4 minus y. And x equals the square root of 4 minus y. So this function is not only 4 minus x squared, it's also 4 minus y rooted. Guys, why do you think I don't have to do plus or minus here? What are these x values? They're all positive. And these y values are also all positive, right? In that first quadrant, exactly. So what's my radius of this cute little cross section of that dot that I just devoured?
Function.
The function, which in this case is?
Root 4 minus y.
Root 4 minus y. Do we have to cancel these out? Because if I didn't, I'd have an outer and an inner. Let's cancel them. So we're saying from 0 to 4, what are we going to get?
4 minus 4.
Antiderivative of 4.
16.
4y minus
Y squared over 2.
from 0 to 4.
There's not.
Pi times 4 times 4 minus final answer. So it says consider the region. 1/2 x minus 1 is this. Y equals 0 is here. Y equals 2 is here. X is 0 is here. We're going around the y-axis.
Oh.
If we're going around the y-axis, what do we look like? A Reese cup. I agree. That was a terrible cross section. What are my cross sections still going to be? Aren't they every time? So you guys, you agree we got a Reese cup coming at us. How do I find the area of this circle? Area of a circle? Pi radius squared. We went around the y-axis. dy. Very good, Nelson. What's my radius going to be? We got to flip it.
2y.
So if I add my 1 over, so I get y plus 1 is a half of an x. Dividing by half is the same as multiplying by 2. So I'd get 2y plus 2 is x. Is that the exact same as 1/2 x minus 1? Sure is. So what's my radius? You got it, 2y plus 2. And then the area of a circle is pi radius squared. We got to go, you guys, what about my bounds? Yeah, because it's on that y-axis. You guys, can I take this antiderivative right now? We got to distribute this. So I can't even inverse chain rule it, to your point, because we got an inner and an outer. We got to distribute this. So what does 2y plus 2 plus 2y times 2 get me?
So my Reese's is 3
4y to the second plus 8y's plus, yeah. Nelson, you okay?
Yeah.
Okay. Let's go take that antiderivative, y'all. My pi is chilling. Antiderivative of 4y squared.
That is weird.
Good call. When I distributed this, buddy.
Oh, you did it like that. Okay.
Yep.
That's what I did wrong.
Yep. Antiderivative, Nelson. Stop. 4y to the what over what? And.
Wait.
8y to the second over second would be 4y squared. And. Good. From 0 to 2. Boom, boom, boom. I'm not even going to plug in a 0 because 0 times 0 plus 0 is going to get me 0. Final answer. You guys, can we just say 4 times 2 cubed over 3? And plus 4 times 2 squared, or 16 plus 8. You could just end it there. So you guys, this is just a reminder. We've already talked about this. To find the volume of a solid, even to find this volume or this volume, what did we add up? Circles on this one, triangles on this one. What did we technically add up? All their cross sections, right? So again, we've written this formula before. We're going to just remind ourselves. Find the volume of anything. We are just going to we're going to add up the area of the cross sections. And as Nelson pointed out, if we're ever revolving, what is that cross section every single time? It's always a circle. Okay, anytime we're revolving, it's always going to be a circle. So, I apologize. I didn't give you much space on this one. But I said, hey, the region enclosed by the x-axis, x is 3, and root x is rotated about the x-axis. Let's remind ourselves, what does root x look like? I like that. I like it. Here's my xy axis. Root x just looks like this. Bloop. They said it's enclosed by the x-axis, and x is 3. And it's rotated about the x-axis. It's rotated about the x-axis. I agree. So we don't have to change the function. It's already with respect to x. And would you say it would look like what shape, bud? It would look like a dot. Sorry, I finished the box.
There's more somewhere.
Okay, here we go. How do I find, what's this cross section? It's a circle. How do I find the volume of a circle? Pi radius squared. What would be this cute little radius here? Agreed. She says it's just the function, root x. What would be my bounds on that x-axis? 0 to 3, exactly. 0 to 3, because we're going on that x-axis. Would we simplify this before we integrated it? Yeah, buddy. So we got pi from 0 to 3. Root x squared would just get me x. Integral of x. Yeah, x squared over 2, and we do that from 0 to 3. So we getting that 1993 AP question point?
Yeah.
Yeah, you're doing that. 3 squared over 2 minus 0 over 2, all that multiplied by pi. Again, Brady, seeing those pies. Guys, you've seen this funnel before, have you not? You've seen this funnel. You just haven't seen part B. So again, this funnel that has a height of 10 inches. The height of this funnel is 10 inches. It has circular cross sections. Would you agree with them?
Yeah.
We have circular cross sections. And it says the radius is given as 1/20th, 3 plus h squared, between 0 and 10. That radius is going to get smaller and bigger, okay? Find the volume. We got this. Volume is just the area of those cross sections added up. So I heard someone say pi. What would be my radius? The function, well said, 1/20th. 3 plus h squared is my function. Volume, area of a circle is pi radius squared. Don't forget the squared out here. From where to where would be my bounds? 0 to 10. Here's the worst part of this problem. Here's the worst part of this problem. Here, it's free response, so we have a little hope. Here's what we have to do first. Do you really want to put in 1/20th and distribute that in and then square all of that without a calculator?
Yes. 1/400.
Is that is 1/20th a constant?
Yeah.
Could I just pull that constant out front? After I do what to it? Because couldn't I just say 1/20th squared is, yeah, what'd you say, bud? Pi over 400, or you could even say, man, I wouldn't have thought about that. I don't care if you say 1/20th squared out there. You know what I'm saying? Because it's a constant, you get to take that out. Yes, Care. She says, excuse me, let's give it a last name. It would be a DH because I used H's there. Great call, Care.
Wait, I have a question.
Yeah.
If you do 1/20th squared, can you leave it like that for the whole thing?
Totally. Totally. Yep. Not a problem. Then you guys, I would have 3 plus h squared squared, which again, I'd still need to distribute before I do any integrating. To Heald's point, you could keep that as 1/20th squared times pi. I'm just going to put it as pi over 400 because I'm getting lazy. Same diff though, right, Heald? Okay. Let's go distribute 3 plus h squared squared. Oh, you guys are going funky order. 3 plus h squared times 3 plus h squared. 9 plus 6h squareds plus an h to the 4th. Now we're ready to take a antiderivative, an integral. Whew, non-calc, but as Brady pointed out, just leave it. As soon as, we haven't even taken an antiderivative yet. I'm getting ahead of myself. Pi over 400 or pi times 1/20th squared. Antiderivative of 9 with respect to h. Plus
2h cubed.
6h cubed over 3 would get me 2h cubed. Amazing, Greer. Plus, beautiful. Then you guys, it's just upper minus lower. Do we need to plug in the 0 here? No, it's just going to get us 0. So am I going to leave that, as Heald said, 1/20th squared times pi, yup, times 9 times 10. You could write 9 times 10 or 90. Plus 2 times 10 cubed. I heard Nelson say, I'm just going to leave it all like unsimplified, and that's great. Who cares? Let's go. Here we go. Here we go. The area bounded by this graph and y is 4 is revolved around y equals 4. Weird. Find the volume, guys. Let's go take a peek. Let's go take a peek. Let's go plug in. This is calculator active, so let's go see what x squared plus 4x plus 4 looks like. And y equals 4. This is funky. It says the area bounded by this blue graph and this y equals 4 red graph. They're talking this region, right? And they're revolving it about this black line.
Is that from -4 to 0?
Yeah, so let's go try to draw that, you guys. So if I'm you on your page, if I were you, I would draw this little parabola. Then I would draw a little y equals 4. And when we revolve it, it's going to be something like this. What candy does that kind of look like that we ate? Kind of looks like that Hershey egg, right?
That looks like a football.
Or a football, agreed.
Football's a candy, bro.
Yeah, that football would not be delicious. Here's what we got to think about here, you guys. Does anything change? Are my cross sections still circles? Yeah, because we're revolving. So all we got to do is since we're around that X, do you agree we're going around this line?
Yeah.
Which axis is that parallel to?
X.
That's parallel to the x-axis. Because it's parallel, everything is still with respect to x. So Sam, good question. Even though they said y is 4, this is actually y is 0, isn't it? So that's why we're good with putting that as x. So you guys, how are we going to find, as Dice asked, my radius? Correct me if I'm wrong, guys. Is this my radius? Is this also my radius?
Yes.
Is green my radius? And is black the radius? So, what's been our mantra this whole year?
Y equals X.
Upper minus lower, hasn't it? So, any way you think of this, Healed, listen up. Any way you think of this, if I wanted to go green radius, if I'm just focusing on green, what would be the upper function there? 4. In this case, it's 4, right? 4 would get me this distance. 4 would get me this whole distance. What would be the lower function?
X squared plus
The function, right? So let me go back. Let me do it over here. If this was 4, upper minus blue of lower, wouldn't that leave me with this green radius? Okay. What if people are like, I wouldn't have thought about it this way. I want to go, this is my upper. I want to do the pink radius. What's pink radius? If I did upper, isn't that the function? Minus, what's my lower here? 4. Is that still going to leave me with that blue radius? Guys, upper minus lower is our friend all day, every day. So I don't care how you think of it. You can do upper of 4 minus lower of the function, or upper of the function minus 4 of the lower. Either way, we got it. What are we going to do for our bounds, though? Calculate where they intersect. So, or when my y is 4, agreed. That'll just take a little longer, right, Stevie, as opposed to intersect? Because if I had to calculate where my y is 4, I'd have to factor this thing.
I'm going to go with -4 and 0.
Yeah, it goes all the way to -4. So we've got a -4 to 0. Upper minus lower. Which you're saying 4 is my upper
Wait, don't forget the pi.
minus, ooh, thank you.
Got you.
My lower is the function. Ooh, the quantity. Greer is helping me out, making sure that I don't forget what, Greer? Parentheses, because we got to subtract the whole function.
And then parentheses outside the 4.
Yeah, because you're saying,
Squaring it.
what are we doing
I
here?
had a double parentheses.
What are we doing? We got to do,
That, John.
yeah, why are we squaring it? Because the area of a circle is pi r squared. Let's see if we can type that in and get the right answer. All right, I got 107.233. We good with that? Guys, what if I wanted to find the area of just this donut, if you will?
Area
We're going back to like 6th grade. Upper minus lower, subtract what?
The area of the smaller circle.
The area of the little circle from the big guy. Does that sound like a little outer minus inner, upper minus lower? Same thing, you guys. So this whole year, that's kind of nice. Calculus is hard enough. At least we get to keep the same mantra. So here's the question. If this big R is referring to this big radius, little r is referring to the white radius, how would I find the area of this? Pi 9 squared minus pi 4 squared. What is 9 squared pi?
81 pi.
Minus is?
76.
60, yeah, 65.
Question. Does anyone remember Mr. Holton?
Yeah.
How he would say this is you find the area of the,
Whole thing.
yeah, but minus the area of the,
Little thing.
Yeah, but how he would say it is you find the area of the whole circle minus the area of the, isn't that cute? That's cute. So you're going to hear me say that. Whole is talking about this whole area. No, how would you know which one is the whole versus the whole? So without a calc right now, let's try this. It says the region bounded by 2 root x. What's the 2 going to do to a root x? Do we really even care? Just going to make it a little higher. But so you guys, what we've got here is we've got, don't really worry about it. It's a root x function. Who cares?
Not me.
Y equals 4.
That's a horizontal.
Horizontal line. Boom. And it says it's revolved about the x-axis.
Okay.
What am I putting, dx or dy?
Yeah.
Dx, okay. Now, people,
Yes.
when I revolve this around that x-axis, don't we need to kind of draw what we had? And then when I revolve it, it's going to be like this. A whole circle and a hole. Okay? So, how would I find the volume of, say, this tornado-looking thing? And maybe it'll help you to draw one more of these circles. Here's my advice when you draw these circles. It is going to be upper minus lower. When you draw your whole and the hole, make sure that they're on the same vertical line, if you know what I'm saying. Make sure that they're on the same vertical line. That'll help it look a little better. But what we're looking for is we've got to find the area of this donut, this tire. Here we go. Here we go. You guys, of these circles, do you agree? Let me do this in green. Is this a radius? Is pink a radius? Okay, doesn't matter. I don't care which one you do. I've heard a lot of people say upper minus lower. I agree. We got to do upper minus lower, and I don't care where we start. I heard Greer say 4. 4 is here. So Greer, if we want to start at 4, I'm good with that. And Greer, 4 is going to be this whole distance here, right? That's my upper. So you're saying to find the area of a circle, we got to do pi
You gotta find the intersection.
r squared, right? Well, we'll come back to the balance real fast. What would be this whole circle's area? Pi r squared. And if we're doing this whole one, what's my radius? 4. So you're saying pi 4 squared is the area of the whole circle. Then don't we have to take away the area of the HOLE? We have to take away the area of this green HOLE. What is this green HOLE's radius going to be? Isn't it 2 root x? Is this radius here? Oop, let me draw that in red.
Yeah.
Time to say the whole, why would you spell out real?
So I got pi r squared minus pi what squared?
2 root x squared.
Yeah, just don't forget that. And then we got to talk bounds.
So I just wrote it like
Why,
with an
couldn't it just be like 4 minus 2 root x squared?
Oh, we'll double check that. That's a great call. I love that you bring that up. We'll double check it. Let's talk bounds real fast though. Without a calc, because we haven't used a calc yet. How would I go figure out where that's intersecting? Set them equal to each other. When does 4 equal 2 root x?
2 equals root x.
2 equals root x.
4 equals x.
So 4 is x. Where are we starting?
4.
Yep.
Is it okay if I just like wrote an extra integral for the 2 root x?
Um,
Pi
yeah. Yep, you're good with that. So you're saying that yours was like this?
something 4 squared.
Yours is like this, bud?
Yeah.
Totally fine.
2 root x.
Here's the deal. We've got to go simplify this before we do anything. I'm going to go simplify my top one. 16 minus 2 squared, root x squared. Beautiful. Yes, thank you. Someone said, can we bring out that constant? Good call, Miss Queen. Unless it was being multiplied by my stuff, I can't bring that constant out front. Great call, because it's pi times radius squared, so we cannot pull that 16 out. Great call. Antiderivative 16? 16x. Antiderivative 4x minus 2x squared from 0 to 4. Okay. I tried to give us a lot on this picture. What does x cubed look like? I don't remember what x cubed looks like. Whoop. So on this picture, this is my x cubed, just as a reminder. Woo, here's my x cubed. I drew that terribly. There's my x cubed. Why did I do this picture this way, Greer? Y equals 0 is here. The x cubed was this part. And then x is 2 is there. So that was just me trying to focus in on just this purple region. We're taking this purple region, and we are revolving it about the y-axis.
Are you kidding me?
You kidding me? So you're saying, oh, okay, if I needed to get x by itself, that is the cube root away. Okay, cool. Therefore, Nelson, you say that this black line right here is the cube root of y? Agreed. What's this blue line, you guys?
It's x equals 2.
Yeah, I've got x equals cube root of y. I wrote that terribly. I'm going to rewrite that. X equals the cube root of y. I'm going to put that there. X equals cube root of y. And also x equals 2. Okay, it's revolved around that y-axis. So you guys, look at what I put in this picture for you. What's this big long one referring to?
The whole.
The hole's what?
Radius.
Radius. Agreed. So maybe I'm going to draw a circle there.
2 squared.
Then what's that green? What's that green referring to?
The whole.
The HOLE's radius. So do we see that we have an HOLE?
Yes.
Okay, and I know it sounds silly, but I do think it helps. Okay.
Said these equal to each other.
Well, let's think.
Yes.
Let's think. If we need to find the area of the whole circle, I'm going to shade it in black. The area of this whole circle is what? How do I find the area of a circle?
Pi squared.
Pi r squared.
2 squared.
Oh, is the whole radius 2 the entire time?
Yes.
Because if I looked at this, isn't that always my upper?
Yes.
Yeah.
Whoa.
Agreed.
It's the whole.
Oh, shoot, what did I say?
You said the whole.
Oh, gosh, that's so embarrassing. 2 squared. Pi 2 squared is the area of the whole.
Yes.
Minus the area of this green HOLE circle.
Y to the 2/3.
Ooh, he's saying this green radius would just be the function. And because we said the function had to be with respect to y as in x equals, we're going to say pi what squared?
Cube.
Cube root of y squared. Yeah.
Good. What do I need to do between that whole area? Yeah.
Minus.
And you agree I can't just do one big parenthesis and square the whole thing. Cannot.
Exactly what I
Abounds on the y-axis. But this one is x is 2.
Yeah. We got to set them equal to each
Oh, yeah. Okay. I could set them equal to each other, or could I plug in a 2 right here? If x is 2, what's 2 cubed?
8.
Oh, okay. Or we could set them equal because we're going to get the same thing. Let me just show you. Cube root of y, you said is 2. How would I get rid of the cube root?
Multiplied by
Cube it
third power.
to the third power.
other. Is it 2/3?
So, yeah, let's practice this one without a calc. Oh, snap. Oh, wait, my bounds. What do we say my bounds are? From where on the y-axis to where?
0 to 8.
0 to 8. Let's simplify first. 2 squared
4.
minus,
Y to the 2/3.
thank you, power over root. Power over root.
32.
Antiderivative 4 with respect to y.
4y.
4y minus y to the,
5/3.
yes.
5/3.
Dividing by 5/3 is times 3/5. So we would be doing this one without a calci because we're bosses. And then, do I have to plug in a 0?
No.
No, that's nice. I'd have a pi times 32 minus, how do we want to write this next part?
24/5.
I would just say 3/5 times 8 to the 5/3. And here's why I'm not going to say 24/5. What do we have to do first with PEMDAS? The exponent. So 8 times 3, I can't do times 24. So don't make those simple mistakes. Just leave it. Now, let's say like this was multiple choice. How would I evaluate this with PEMDAS? Do you really want to do 8 to the 5th power?
No.
Certainly not. I have no idea what that'd be. I'm actually kind of curious. What is 8 to the 5th power? Okay, yeah, 32,768. Cube root of that. We don't know.
Which is 32.
But the nice, yeah, there you go. The cube root of 8 is what?
2.
2 now to the 5th? 32 times 3.
Is 96.
Yes. Fifths. I'm good with us ending there.